Okay, so thanks for everyone coming here today. So today I'm going to introduce to you guys Andromeda. So first I'm going to get barely into myself a little. I essentially have started with the Nova team. So we started building a JavaScript engine, and then off of that we decided to go straight into building a runtime. So the idea was essentially if we could build a runtime on top of the JavaScript engine, we can know exactly where to, essentially what features we need to implement for Nova to begin with. And then after that, it just got more advanced, and then it got more fun to implement, and then we just kept going from there. So I'll get right into this. In this slideshow, I'm going to introduce to you what is Andromeda, how it works, what problems it tries to solve, and what's possible today, and where it might go in the future. So this is not a full runtime, just full case disclosed at the moment. We are not feature complete. This is still in its early stages. We're getting there. There are some unique use cases and some unique features that some other runtimes don't have, and I'll get into that very shortly. Okay. So why in the world would we build a new JavaScript or TypeScript runtime? We have plenty out there. They release like every day at this point. It's the new trend after creating endless JavaScript frameworks. Now I guess we're going with runtimes. So essentially, why did we start? So essentially with most of the runtimes nowadays, they're all essentially node compliant. So that can be a good thing and a bad thing. So essentially, any existing project can easily run in Node or Dino or Bun, and essentially barely need to change the code, and it's expected to have the same behavior for a bunch of those runtimes for any like node compatibility. So we don't have that yet, or yet as in we don't plan to have that built in by default. There are maybe plans to have some node compatibility as a feature that you would need to individually compile, or if we released a custom build including that. So just there's also a huge issue with JavaScript in general is just the config files. In your projects, a lot of times the config files will take up a lot more space than any of the other JavaScript files. You'll have like one JavaScript file and then like 5 different config files for just running a simple command line. So essentially with Andromeda, the philosophy is you need the least amount of config as you need. You can have an Andromeda JSON file to configure some things, but it is completely optional, as is usually handled in Dino as well. So essentially, and another big issue with these runtimes is backward compatibility. So essentially, a lot of these APIs are completely out of date and are replaced with new APIs. And a big issue with that is just the accumulated complexity of the runtime itself. So essentially, by having every single feature in this runtime separated, you can easily disable any like API, and each API is really easy to import. With the actual runtime itself, if you use that as a library, you can essentially choose which built-in extensions or built-in APIs you can include, which include like so far we have like Web Crypto API, Fetch API, a Serve API. Essentially, we have and yeah, many more, including like a Canvas API, which I'll get more into in a little. Yeah, so essentially, where the timeline, as I got into a little bit earlier, so we started with Nova. So this project was led by Appa, who's actually going to be doing a talk later today, so you guys can get more information, and I'm going to not go into as much depth with Nova as Appa will later on, and I very much recommend you watch that talk too. So just there's lots of gaps in these runtimes, as in with Dino, I think that kind of bridges the gap a little more, where APIs are a lot more accessible than they would be with Node, which is a good and bad thing. With imports make it easier for essentially linting, and because you don't need to, or it makes faster linting essentially in some cases, because you don't need because you're not checking the entire API, you're just checking what you're importing. So, but and yeah, so for now we've gone with the Dino philosophy for having a central Andromeda keyword, which or Andromeda namespace, and essentially with that we have most or very similar APIs to Dino at the moment. Some APIs, which I'll go into later, are also inspired by some newer Node ones. But with the Spark, essentially. So a big thing that sparked the development of Andromeda was implementing TypeScript directly into Nova. So the benefit of that was based on the ECMAScript proposal by Microsoft for essentially TypeScripting directly into JavaScript. By implementing or by using the OXC API, we've been able to essentially parse all of TypeScript and essentially treat that as comments. So the only things that aren't treated as comments would be, at the moment, enums, which we do handle as if you would handle an enum in a native JavaScript setting. So essentially, yeah, having that all implemented into Nova, nowadays TypeScript and runtimes tend to go together with better LSPs, better linting, better error handling. It just makes life a lot easier these days by just having TypeScript. So essentially, by having TypeScript directly into Nova, it just made it really easy to just build an entire runtime off of that. And yep, and we should keep refining and expanding the APIs as it goes. And yeah, bring simplicity and speed back to the JavaScript ecosystem. Yep. So essentially, unlike many runtimes, we're just fully written in Rust, including the Nova engine is also written in Rust. This gives us the ability to control things at very low level and go up from there, if we have full control over the ecosystem in that way. So I'll get a little more into Nova again later, and Appa will continue that as well. But essentially, a big feature of Nova is the data-oriented design, which I'm not going to go into full detail about. That's a little more a complex topic, which Appa is going to explain later. But essentially, another big benefit of this of Andromeda so far is the GPU accelerated canvas. So essentially, we wrote an entire web GPU renderer for the Canvas API. It is not feature complete at the moment, but it does support some basic stuff. Okay, so yeah. Also, I was talking about Node APIs earlier. So essentially, we do support the SQLite API based entirely on the Node spec. Because I did end up liking what they did spec-wise, and I personally think it's very good looking. Yeah, and also yeah, there's by having Rust all the way there, we have by default memory safety. So there's a lot less undefined behaviors that could happen if it was written in C++ or if there was any C++ in there. So again, who should use it, where it fits, all that stuff, right? So a good place for this to be used would be runtime researchers. So people building on new toolings, the Andromeda API is built to be intuitive, give very much a lot of control to the developer. If you easily want to write your own API, you can include all the other Andromeda APIs if you want, and essentially you can. So essentially by default we have graphics, so that can help essentially if you want to create some visualizations, generating like PNG files, or like essentially maybe even generating slideshows, which is not the case for this one. But yeah, another big benefit would be like scripts. Since there's minimal config, scripts are you can just easily just write a TypeScript script and then just run it instantly. So, and another big benefit would be edge runtimes. So if you want to build an edge runtime for specific cases, you want to disable certain features, you don't have full control over your runtime, essentially. If you want to disable, I'm going to go a little more into Nova here, but for Nova, I did implement the ability to disable various JavaScript APIs directly in as a feature. So essentially, a few of these APIs will include like the math API. So essentially, if you want to create an edge runtime, and for some reason you want like someone using a custom like math API and have like no access to that, you could essentially just disable that directly in Nova and build up your runtime from there. So, and also, yeah, microservices would also be beneficial just based on simplicity alone. So, what is the architecture for this? So essentially, as mentioned earlier, we start with a Rust core. Then on top of that, we have the Nova engine integration, or engine just on top of that. And so based on that, we have the module loaders. So essentially for now, we can handle TypeScript, JavaScript file imports. Eventually, I do plan on expanding this API to also allow you to handle your own custom files if you really want to, and essentially be able to parse that yourself. So yeah, another big benefit of this is we are trying to be as web standard compliant as we can. So we are part of the WinterTC organization or working group, and based on this, we're trying to follow the web interoperability standards. Andrew actually has a talk on this later, so and we'll get more into that as well. So yeah, just the built-in tooling ecosystem. I did not get into this a little bit earlier, but since we don't handle type checking by default, so far we have a check command, and based on that, that can handle our own custom TypeScript. There, we might have some more basically ideas on integration later on with should we use the actual TypeScript compiler for type checking? Like, does that help with because if we can't keep up with the TypeScript standards, just based on our own custom custom handling, then we can just essentially potentially use the TypeScript or the TSC step for that. So another benefit is we currently have a semi-working LSP. So we have started a VS Code extension recently. It sort of works, as in if you essentially debug the VS Code extension, it works perfectly, but as soon as you compile it, it doesn't work at all. So we're going to have to figure out what is wrong with that and how we go from there. So just the stack in general. So we do use the OXE-based toolchain, which is part of the Void Zero project. So what I found is this what's called toolchain is really beneficial. It really easily handles parsing. It really easily handles essentially like linting, formatting, resolving imports, and all that, and so on. So that's been really beneficial to just have directly all written in Rust and being able to just have a full Rust ecosystem. So the Nova JavaScript and TypeScript engine. So essentially we integrate a new JavaScript engine as essentially most runtimes we have these days tend to either run on the V8 engine, SpiderMonkey, others. And so essentially by starting with our own what's called JS engine led by Oppo, we essentially this does give us the spec, what's called some spec issues, as in we do need to fully implement. It's still an early stage engine. It's getting better, but and it's progressing quickly. But still, we do have steps to go from here. Yep, and again, going with we comply with the WinterTC standards. So essentially, we want minimum common surface area with web and server-side runtimes. So essentially, being able to easily translate your code from a web app to a server-side app and back and forth without with minimal code changes. So, what is the Nova JavaScript engine? So essentially, the ECMAScript specification is in general for what's called for JavaScript tends to be very object oriented. oriented and inheritance heavy. So structural inheritance makes subclasses only grow when common usage is more clearly defined. So such as consider property maps, weak maps, array buffers. So essentially, Nova is built from special cases up instead of common cases down. So special objects inherit base objects using pointer indirect composition. So essentially, an array buffer could be as small as 16 bytes. So we do also have some experimental features coming, which Oppo will get more into. I very much recommend that you do listen to that talk. I haven't gone too deep into Nova, and there's a lot of things you guys should know about. So yeah, essentially some experimental features could be vector-based heap, tagged indices. So this could all end pretty badly, but for now it's looking good. Okay. So native TypeScript support. So essentially, reiterating this again, just the simplicity of writing a single TypeScript file, being able to run that directly into the runtime without a separate TSC step. So again, we do handle internal enum transpilation inside the Nova engine itself. It handles it as it would handle like a const object at the moment. So essentially, this ensures a good developer experience, minimal friction. There's lots less configuration options for your TypeScript runtime, so it makes it a lot less difficult for running one version of TypeScript in another if it all just handles TypeScripting just directly. So there are also challenges and trade-offs. So the startup costs and validation for large projects. Then also dependency graphs can be a pain. We are looking into more future caching options to be able to cache some more imports as long as it's not, as the file hasn't been edited, for essentially to get some better speed for this. So essentially, what APIs do we have? So far, I've gone into a few of them, but here's how Andromeda differentiates from just a plain JavaScript shell. So essentially, we do have the file system or APIs. They're very much based on Deno, but they do differ. Feel free to check the Andromeda documentation to see exactly how this is handled. We'll get more into that a little bit later. So essentially, we do also support fetch and basic HTTP server handling at the moment. And we do support basic web crypto APIs as well. Again, reiterating the canvas, which is fully written using a WebGPU renderer, which we fully wrote, which can be a plus and a minus. Having to maintain that entire project is a minus, but also the plus is we have full control over that as well. So again, SQLite support is also based directly on the Node API for spec. And then we also feature some basic web APIs at the moment, like the text encoder, text decoder. Streams are almost there fully. Performance is there, and URL APIs, etc. So also reiterating some more tooling APIs, we do have a bundler, which is handled using OXC at the moment. And we do have a language server processor, as mentioned earlier. It's not fully working, but it kind of works. And also a big benefit has been a self-updater. So a lot of languages don't support that. And I think this is a huge benefit of being able to just update your code update your runtime without having to reinstall a new runtime. That just the developer experience is not great for that. So, and also we do have a compiler. The compiler isn't great yet, since we essentially compile all of Andromeda into the binary. Eventually, we do have plans for a separate parsing step in case that you can enable that would essentially detect or read the entire all the dependencies, figure out which exact APIs are enabled or are included in your code, and based on that, exclude some APIs which are not needed. This is still a very ambitious step, and we haven't gotten there yet, but it is on the roadmap. So Safety, permissions, and security model. So again, reiterating, the Rust Foundation gives us memory safety, no undefined behaviors, having a future permission-based system. So at the moment, we do have everything enabled by features, but having a permission-based system to essentially like Dino implemented and then Node started to implement as well. So supporting something like that could also be very, very beneficial for security, and that's definitely something we are looking into as well. So just there's just a minimal attack surface. Having a lot less legacy APIs benefits us in it's harder to exploit. You have more control over which specific APIs are enabled. The less APIs, the easier it is to monitor. So also, yeah, there's secure cryptographic primitives using the Web Crypto API, fully based on the web standard for that. And yeah, then there's auditable boundaries with explicit host API exposure. Yeah. So yeah. So installing. So here so far I have just some basic install steps for Andromeda so far. So as you can see, we do have the basic Windows install script here. Also, we did get the package published onto winget. So we do also have a winget package now. So feel free to install it this way as well. And also, for Mac and Linux, we do have a bash script as well. So, example and use cases. So for here today, for our example, I have essentially written a script to generate this QR code here, which you can scan and access the Andromeda website directly. Essentially, what we're doing here is we're just creating an off-screen canvas using the off-screen canvas API for the web. And then getting the 2D context. I did not include the entire QR code pattern, but it is a 2D array filled with zeros and ones for binary. But yeah, and then essentially we're filling the rectangle, the background, setting the fill style to this specific color, and just going through the rows and the columns and essentially just drawing the rectangles. So feel free to scan this now. I will have this QR code up later at the end as well. So what's next? So better plugin or extension systems. So FFI is a huge plus. Being able to import FFI modules will add better interoperability with other compiled languages that can compile to libraries. Another benefit could be potential NPM support. So having an NPM as a feature as opposed and not enabled by default. So essentially, if you did want some compatibility, eventually we could get some of that working, because there's essentially, as long as we're not getting too complex, there's no reason not to. So then there's just what's next. We do need some more ecosystem growth. So we need more contributors, more libraries, more modules, more wrappers, all that fun stuff. So far, it is still early steps, so the performance isn't quite there. But we'll get more into some more performance enhancements later, or potential performance enhancements. So again, reiterating again, you guys should definitely see or listen to that talk later. So then also some optimizations. So a big downside of not compiling the TypeScript would be just the whole parsing step. It's essentially for like one file, it's not much, but essentially as your project gets bigger, essentially you're just parsing all that, which could be interpreted as somewhat as like parsing comments, but we are working on some performance enhancements for that. So tooling maturity. A huge benefit could actually be the potential addition of an LLM as an extension that you can include into a debugger or into a type checker that could essentially describe what the error could be, potential fixes for it. This would also be completely optional and would have to be enabled as a setting. So obviously we do need a lot more community contributions. Feel free to open issues, open pull requests, join the Discord server, and feel free to just ask anything. We'd love to communicate. communicate with just anyone. Yeah. So what are the risks, trade-offs, and questions? So again, the ecosystem compatibility. Since we're not trying directly to compete with Node, we're trying to set ourselves apart. A big downside could be the Node C++ API. So we don't really have any plans of supporting that. That's kind of it does add a lot of memory on safety to your code, and we don't really have any plans on supporting that at the moment, but maybe basic NPM support in the future, that could be a benefit. So also maintenance overhead and project stability. So just keeping performance and memory usage under control on a complex application is hard. So without good debugging and observability, the adaptation will lag. So again, I'm going to encourage real-world feedback. That would be great. If anyone can just feel free to say anything, even just say hi, that would improve the community. So again, I'm going to emphasize again, Andromeda is not perfect yet, but the ambition is to grow and improve. Potential growth for the migration path. Yep. And what to remember from this talk in general. So I want to reiterate the design philosophy. So subtractions, clarity, transparency. So I encourage everyone to think beyond node plus bundler plus compile approach, and essentially consider this new approach we have, or new-ish approach we have with Andromeda with So also, yeah, the future of runtimes is still being written. All these existing runtimes are great, and we're not trying to essentially compete with them. We're trying to pave our own way with Andromeda and create our own niche in the JavaScript runtime ecosystem. Yep. So yeah, feel free to try it out. Here's the QR code generated earlier as well. So yeah, feel free to visit the tryandromeda.dev website. We have docs there, getting started, examples, all that fun stuff. Feel free to start the GitHub repo, join the Discord. You can find that directly on the website or on the GitHub repo as well. And yeah, feel free to, we'd love to see sample projects, various experiments with the APIs. Feel free to submit them to us. And yeah, so feel free to propose APIs, debug tests, and we just love any feedback in general. Okay. Any questions?
Okay.
If you had to briefly summarize, like, what would be...
Oh, sorry. I will bring a mic.
If you had to briefly summarize, like, what would be some of the main reasons for using this over Bun or something?
Yep. So essentially, just like if you want to create your own custom runtime, this is a huge benefit. So a lot of these like edge providers are creating their own custom build, like basically these custom APIs. So at the moment, this is it's very beneficial to essentially. We have the whole system as a library to begin with, and then we have our custom CLI, which has all the required APIs. So essentially, if you just import the actual library, you can build your own runtime on top of that. So it's just, we have a lot of just, it's more for developer experience at the moment, where you can just build your own custom runtime on top of this.
Sorry, quick follow-up. So
Yep.
like, what would be a core use case for building your own runtime?
Yeah. So essentially, with graphic support, we have a lot of these basically these applications that are just deployed, which essentially can generate graphics just on the server side. A lot of those require external APIs when we have a perfect Canvas API in the browser already, and you might as well, if we have that built in, it just adds the easy developer experience of being able to essentially just like not even have to import anything. Just essentially just using the Canvas. Essentially, if you know how the browser Canvas works, it's just very intuitive to get started.
Thank you.
Okay.
Yeah, so we don't have enough time.
No, time
Thank
for
you
more
so much for
questions.
coming. Yeah, and thanks so much.